Hello. What's next with this study of quartiles and measures of spread? Um, we need a way of visually representing all that information. Okay, so if you just glance at a list of data, it might not be clear at first sort of how spread out it is. So a way of putting it on some kind of chart or number line is a much better way to get that sense of how spread out the data is very quickly. Okay, so firstly we take everything we learnt before and also the lowest and highest values of the list. So lowest value 9, got quartiles 24 and 70, median 34, highest value 81. What we call this is what we call the 5-number summary. Okay, and we use these 5 amounts to then plot them on the number line with a little vertical line as I'm doing here. So that was the lowest value at 9, quartile 1 at 24, median at 34, again, quartile 3 at 70 out there, highest value at 81. Then we're going to join all these up in a very specific way. We're going to make a little box with that goes from quartile 1 to quartile 3, above and below, like so. Okay, a box. Then we're just going to join the box up to the highest and lowest values with a line in the middle there. Okay, and what we have here is called a box and whisker plot. Okay, you can see the box in the middle and the what we call whiskers going out to the highest and lowest values. Okay, and we can see now various bits of information straight away. We could find out the interquartile range by the width of the box, or the range straight away. Okay, so remember these 5 vertical lines were the lowest value, quartile 1, median, quartile 3, and highest value. Okay, it can get a little bit more complicated there. If we go back to the original list that we were looking at in the last video, we were talking about how some data points were outliers, and well, that actually has a very specific mathematical meaning, and is something that we can show in the box and whisker plot as well. Okay, so here we have our previous list. Now we could go ahead and plot the 5-number summary just as we did below. So that would be 2, 6, 7, yeah, then quartile 3, 8.5, and highest value 28. We could join them up again with our box in the middle and then our whiskers, but this does not take into account the fact that some of them may have been what we call outliers. So let's get rid of that and have a think about what outlier might mean exactly. Is 28 an outlier? Is 16? Maybe 2? The definition we give to it exactly is we take the amount of the interquartile range, which we found before was 2.5, and we say that if a data point is more than 1.5 times the interquartile range above quartile 3 or below quartile 1, then they are outliers. So 1.5 times the interquartile range is 3.75. So 3.75 above quartile 3 would be anything that's above 12.25. And we see that actually 2 of our points here are technically outliers, 16 and 28. But we look at below as well and see whether we have any lower outliers. So basically 3.75 below 6. That's 2.25. So anything below 2.25 will be an outlier as well. Okay, so 2 is an outlier also. Now we can plot these alongside our box and whisker plot with a little cross. So we do a little cross at 2, 1 at 16, and 1 at 28. We're going to call 3 and 10 our new lowest and highest values, and go ahead and put those 5 vertical lines in just as we did before. Okay, and join them up with a box and whiskers. Now, these outliers could have been just a freak occurrence. They could have been some kind of chemistry experiment where we actually made a mistake. And there's all kind of reasons why we might actually want to discount these as not really valid in our study of the data, or at least separate from our study of the main body of the data. Okay, so those crosses there are outliers, okay, but we still have a box and whisker plot for the rest of the data.